All right. Hey, everybody. My name is Michelle Proscia. I am the Ag Program Manager in Cornell Cooperative Extension in Sullivan County. That's in New York. I know we have a wide range of individuals and farms who are joining us from across the country, so that's great. I'm really glad to have that. This is the Livestock Genetics webinar. So we have the great pleasure of having Dr. Adam Murray with us today, and I'll have him introduce himself in a moment. Also with us, we have Catherine Brignac, who is from Cornell Cooperative Extension in Ulster County, Zoe Lockburner, who is Cornell Cooperative Extension in Orange County. And if there are any other extension educators, you can go ahead and throw your information down in the chat box if if you need to reach out to them if they're in your region. Other states, check online for your local cooperative extension. In just a couple housekeeping notes real quick before we get started. We did have over 150 registered. I realize that there is not going to be that many people on with us tonight. However, there is still a large group. So if you would be so kind as to mute, and we will have the chat box available, and we will be monitoring that. If there are any questions, throw them down there as the presentation goes on. And Catherine is happy enough to check them out and read through and answer questions as we go, as long as it's pertinent to the presentation that we're going through. Otherwise, we'll follow up at the end and open it up for questions for everybody. With that, I will yield over to Dr. Murray, who has graciously allowed us to have this class today. So thank you so much.
Oh, thank you very much, Michelle. It's great that we have such a turnout for this. I was kind of joking leading when we were prepping for this meeting that I just got a weather alert on my phone for a snow squall, and that's not something I've ever gotten in Virginia. So hopefully our internet stays solid. I'm like Michelle said, Adam Murray, originally from Virginia, so I did my school back and forth between Virginia Tech and Texas A&M, focusing on actually meat science and ruminant nutrition. I did my master's at Texas A&M in 2016 in meat science, was a part of the quality audit team, and finished up my Ph.D. in ruminant nutrition, would have been February of 2024. I just started my role here at Cornell as the PRO Livestock State Extension Specialist, would have been in September. So really happy to be settling in here. And, I partner, I guess, all my schooling with a lifetime of experience raising cattle on my family's small Angus cow-calf herd back home in Virginia. We also dabbled in kind of some crossbred and Simmental as well. So as I'm sharing my screen here, or at least trying to get it all squared away, let's see. All right, what screen are y'all seeing?
Looks
We
like
can see your notes.
Yeah.
Oh, I got it backwards then. How about that one?
There we go.
Yep.
Should be a title screen. Great. So I titled this talk just Genetics for the Cattleman, and just because I'm not going to go over a lot of detailed, you need to be looking for this specific number or this specific trait. I really, as I was putting this presentation together, I wanted to focus on a high level, genetics, what producers can do to implement into their herd. We'll talk about some technologies and what that are pertinent to EPDs and genetic selection tools, and we'll round off with kind of some bull buying exercises, I guess, and some points to consider. So and of course, it's not changing slides. There we go. So when we talk about any trait, doesn't matter whether it's hair coat, weaning weight, milking ability, no matter what it might be, the components of performance are an interaction between the genetics and the environment, right? So I have a pie chart up on here. It's just kind of an arbitrary slice that I've pulled out, but really any trait is going to be a combination of those two. And when we talk about the environment, we're talking about a multitude of things, right? It could be our feeding regimen, whether these are cattle receiving grains and brewers grains, corn, wheat, whether they're solely on pasture, a combination of the two. The environmental conditions are going to be play a lot into that. I'll kind of get into some specific traits and EPDs later about that. Pasture layout here in New York, when we have a lot of hillsides and a lot of topography, I guess, for lack of better words, it's going to be a lot different than flat plains out in Oklahoma or whatever it might be. So just because we have a specific genetic background, it's not going to, play the full range of how the phenotype is presented. We really talk about this interaction between genetics and environment. So we can talk about our simple traits, right? Our single gene traits like hair coat, polled versus horned. And that's when we go back to our familiar Punnett square. So I have some examples here to the right, looking at hair color or coat color, excuse me, where we can talk about our basic dominant and recessive traits. So for a single gene trait like hair coat, we have the sire and the dam will each provide one copy of the gene. So each parent has two copies of the gene from their parents, and they will pass on either the dominant, which would be in this example the capital letters. So in the top right corner, where we have a black sire and a black dam with the dominant trait being black. We have ED as being the dominant black trait, and we see on the left, our dam side, the lowercase e as a recessive. So because black is the dominant trait, whether you have a recessive gene or not, the offspring will always result in a black coat. Now, when we get into two or more parents with recessive traits, like we see in our bottom left corner with the lowercase e, we have a 25% chance of, even though we have a black sire and a black dam, if both of those parents have the recessive trait for red, while black is dominant and they are presenting the black phenotype, there's a 25% chance that red phenotype will be passed on. So for simple traits, genetics are pretty easy, right? Hair coat, black is going to be the dominant phenotype. Polled is going to be dominant in horns. But when we get into some more complex traits like growth and marbling, we have a lot of different genes that are playing into that, a lot of different avenues for these traits to be affected, right? So I like to think of it in terms of really kind of two simple bar graphs, right? So I'm using marbling as an example because I'm a meat scientist at heart. If we have our environmental management, which we see in this red column with the E on it, and our genetic potential with the white column with G, right? So if we have a low genetic potential, it doesn't matter how well we manage these cattle. It doesn't matter what sort of elite feed resources we have. If the genetic potential is very, very low, we're probably still going to wind up with a low marbling grade, right? You can't turn iron into gold to some degree. If we look at it from the reverse, if we have a very high genetic potential, so very high potential for marbling, but our environmental management is low, we still might not be getting the full potential of that trait. So we might do a little bit better than select. We might get into, choice because we have that high genetic potential. But ideally, what we want to see is our genetic potential and our environmental management matching each other, right? So we have high environmental management, whether that's feeding regimen, whatever that might be, and high genetic potential. That's how we get the full presentation of that trait, right? So that's how we get our prime marbling, our full potential of this animal in this example. So when we're talking about specifically the genetic component of performance, really our best tool for that is going to be EPDs, right? So only the genotype is passed on from one generation to the next. So when we talk about genetics, our focus as livestock breeders is to measure or estimate that genetic potential to the best of our ability so we can improve our economically important traits. So what are EPDs? Very basically, EPD stands for expected progeny difference. So this is the estimation of an individual and the genetic value of this individual as a potential parent. So what genetic potential are the sire and the dam each bringing to the table, basically. I have this very simple example on the right. We have bull A with a weaning weight EPD of plus 10 and bull B with a weaning weight EPD of plus 60. So if we randomly mated both of these bulls to 10 similar cows, we would expect on average the offspring of bull B to have these calves are going to have a weaning weight that are going to be 50 pounds heavier than the average of bull A. So I say average specifically because EPDs do not predict uniformity and they do not predict specific weights, right? So that weaning weight EPD of plus 60 does not mean that you will always get a calf that is weaned at 660 pounds, right? Remember, there's an environmental component that goes into this. There's a lot of different factors. We're talking about the average. So I like this figure that I have on the left. It really kind of spells it out well. We can still have some variance among our progeny, right? So every sire is going to throw good ones, every sire is going to throw bad ones. But in this example, we have a sire with a weaning weight EPD of plus 10. He might have 5 different calves with 5 different weaning weights that are measured, and have 5 different individual weaning weight EPDs themselves. But on average, if we have enough progeny, the average of the average trait, average weaning weight measure of the calves out of this sire will have a plus 10 EPD. So these EPDs, it's important to point out that they are predicting differences in progeny within the same breed. So we cannot directly compare an Angus calving ease EPD to a Brahman calving ease EPD to a Charolais calving ease EPD. These records are maintained and updated through the breed associations. So I have the table here on the right. It's actually from the Beef Improvement Federation, the BIF. They put one out every year using crossbreeding data from the U.S. Mark Research Facility in Clay Center, Nebraska. We are able, if we want to use these conversion factors to compare Angus EPDs to Simmental EPDs or Gelbvieh or whatever other breed we might want to compare to. We can use these conversion factors to do an apples to apples EPD comparison. But it's important to point out that these EPDs, the averages, are going to be different, and there are going to be slightly different variances between breeds. And again, those are maintained by the breed associations themselves. So we know what EPDs are. We know what they stand for. We know they're talking about the average progeny performance. But how do we go about improving these EPDs, right? So there's a lot of different data that goes into these genetic selection tools, right? So when we have a breeding, any sire, any dam, whatever it might be, we have tens of thousands, if not millions of genes that are randomly being assorted and combined in that when that sperm meets that egg at conception. So it's really impossible to predict how each gene is going to be combined and how it's going to play out for the offspring for this potential mating. So when we have EPDs initially for a newborn bull or a newborn heifer, it's initially just the average of the sire and the dam for those traits. As we add more data to this model, these EPDs become a more valuable tool and they have better predictive capabilities, right? So we can add that individual's own performance. We can take hip height measures. We can do yearling weight. We can do scrotal circumference. We can collect all of this data, submit it to our breed associations. They will update that individual's EPD. We can also, these EPDs will be updated by sire and dam data as it gets submitted, progeny, other relatives. All of this will add to the genetic predictive model that go into these EPDs. The breed associations will also look at correlations between traits, right? So birth weight, for example, I have in that second bullet point, is going to be highly correlated to the calving ease EPD. Yearling height is going to have an influence on the dollar energy, and we'll get into the definitions of some of these specific traits later. But there are genetic models that are put together by years and years and years of research and statistical analysis that these breed associations use that when data is submitted to update EPDs. And they will usually put out at a bare minimum, a spring and a fall updated registry for, percentile averages across the breed. But most of the time, when you're submitting data, depending on the time of year, that individual animal's data can be updated within a couple weeks to a month. There's also some adjustment factors that go into when producers submit data that will influence how that data is interpreted and weighted, I guess, for lack of better words. So if you're submitting weaning weight data, they will ask you if these calves were creep fed or not, because obviously if we're providing creep feed and some form of grain or supplement to our calves, that's going to influence our weaning weight, specifically above what just the genetic potential and the dam's milking ability is going to be. So there's a lot of different things that go into these specific EPD models. So I have an example here. We have Deer Valley Growth Fund, an Angus bull up on the left. These are actually this is his actual EP or yearling weight EPD values that I looked up the other day. I guess they're true as of the 27th of January 2025. So he is a very, very well-known bull, very heavily used bull, so very high accuracy rate and a very, very high favorable yearling weight trait. I just Googled a picture, Googled an Angus cow and found me a female that I liked, and I just kind of made up some values for her. So these are kind of arbitrary values for the dam on the top right and this hypothetical offspring at the bottom. But as I was talking about earlier, so we have this mating and we register this hypothetical heifer calf, and that yearling weight EPD of 137 is just the pure average of 168 and 106 from the dam. But say as we raise this heifer, we submit her individual weaning weight. So we take her, adjusted 205 day weight, we submit that to the Angus Association, and now her yearling weight gets updated. Now it's maybe gone from this 137 now to 140, and her accuracy's gone up a little bit. And then maybe we decide to collect some genomic data. We take a blood card on her and we send that data in. And this is adding more data, again, to the EPD model. So now her yearling weight's been updated again. We've gone from 140 to 146, and that accuracy's bumped up again. And maybe we flush this heifer, or, with years of breeding, we submit a lot of progeny records to the Angus Association, and we have more data. So this her EPD or yearling weight EPD value continues to be updated. So when we started with this heifer calf, newborn heifer calf with a very low accuracy and just a pure average of the sire and dam yearling weight trait, as we submit data and as we add more data to this predictive model, we get closer to this animal's true value of what her actual yearling weight potential is going to be. So, I mean, I'm an optimist. So in this example, the yearling weight kept going up, but in reality, traits can go up and or down depending on the data selected. So it's all, all just kind of depends on what data and what measurements are submitted. So as I've gone about and talked with producers, we get a lot of questions on, what is this genomic data? How does that influence our EPDs, and what does this mean when I submit it? So I wanted to get into that a little bit and talk about genomic testing. So we mentioned the Punnett square earlier, and how sires and dams each have, two gene alleles for each trait, and it's random on which one from the sire and which one from the dam gets passed on to the offspring. Well, DNA itself is organized into base pairs. So we have adenine and thymine, guanine and cytosine. So all of the hundreds of thousands, if not millions of genes in the cattle genome is just a combination of A's, T's, G's, and C's, right? And when we talk about DNA, I'm not going to get into the specifics and bore y'all with a biology lesson, but basically DNA is the coding for proteins. So proteins are what get things done in any biological system, right? So a DNA will code for a protein, and that protein or that combination of proteins will create the trait or create the the phenotype, basically. So when we talk about genomic testing, we are taking we are looking at the A's, T's, G's, and C's, right? Looking at the combinations of these DNA base pairs within genes and within traits. And through a lot of research and a lot of statistical analysis, we can look at differences in this DNA code and we can relate that to specific traits. So what makes genomic testing really, really valuable is it almost immediately enhances the EPD and pedigree data. So looking back to our, example a few slides ago, you'll remember that the accuracy of that hypothetical yearling weight was 0.05, meaning a 5% accuracy. There's a lot of variance in that. When we take and submit genomic data, we can immediately boost the accuracy of a lot of different traits. So depending on the trait, submitting genomic data is the equivalent of having 8 to 20 progeny worth of data. And so we can, as long as we can collect blood on an animal or collect a tissue sample or a hair follicle, we can submit that data. So we can, in theory, have a week-old calf, collect some blood, send that in, and when that data comes back, even though that animal is maybe only a month old now, with this genomic data, we have the accurate the EPD data of the equivalent of 8 to 20 different progeny. So we can increase the rate of selection pressure very, very quickly. We don't have to wait year after year to get one calf at a time, or even if we're flushing animals and putting in embryos, we can get a return data very, very quickly. And it also provides insight on some traits that are pretty hard to measure, right? So not everyone can collect carcass data from their calves that they're sending off, but we have genomic data that can give inference on, carcass data, milk production, heifer fertility, hair shedding scores, etc. So there's a lot of valuable information that come very quickly using genomic data to enhance our EPDs and at a fairly reasonable cost. So I looked up right before this presentation. I have down here, kind of in the bottom left corner, I'm an Angus man mainly, so I'm going to use Angus a lot for my examples, but we have the Angus gene source from Neogen or I believe it's Pfizer HD 50K genomic test. Those are kind of the two prominent ones. Those are $37 per test. So they're fairly low, very low input cost compared to the data you're getting back. I looked up the Hereford Association. They have packages running from $30 to $75 per test, and the Simmental Association about $50 per test. So very, very affordable, very approachable test. Economic or cost, excuse me, approachable cost, especially for the data we get back. And I say packages because we have the opportunity to get some indirect production data as well. So not only will you get data back on birth weight or docility or marbling score, all these, variety of different traits that I have here on the right, but we can also get, confirmed parentage. So if we have multiple bulls running in a herd of heifers and cows, we can see which bull sired that calf. We can get some coat color information back on whether they're homozygous black, if we're talking about Simmentals or some of the other colored breeds, or diluter genes. But I have underlined here genetic disorders. We have the opportunity to, when we send in that blood test, to also get some data on whether or not these potential breeding animals are carrying genetic defects like arthrogryposis multiplex, which a lot of people refer to as curly calf, or dwarfism, or a variety of different different genetic disorders that can lead to abortions and negative outcomes on calves. We have the opportunity to get some of that data back when we send in our blood test or tissue sample or whatever it might be. So I always recommend to producers, they ask, when should I do genomic testing? My rule of thumb is always to go through and make your culling decisions based on phenotype first, right? So the phenotype is going to be the expression of the genes. How that animal looks is really going to be a good indicator of, what kind of productive genes are expressed in that genome. an animal can have outstanding numbers, but if it's post-legged and straight as can be, and we're looking to keep a bull in our herd and it has great numbers, but he's straight as can be in the hind end and he's going to blow out his stifle, that's not necessarily valuable to us. So I recommend producers making culling decisions based on phenotype first, and once they've made that first round of culling decisions, then go through and collect your blood or tissue or hair sample follicle, whatever it might be, and sending in those for genomic testing. And that might save you some money, so you're not testing an animal that you're going to cull because it doesn't quite have the right look that you're looking for anyway. So I keep bringing up this term accuracy, right? So we have, talking about how close to the true value of a trait the EPDs are predicting. Accuracy is going to be really, really important on how we value the data, right? So accuracy can range from 0.00 to 1.00, with 0.0 meaning there is no relationship at all to that EPD value and what is actually being transmitted to progeny, with a 1.0 meaning it's right close to perfect, right? So we are spot on with that target. So as we submit more data, whether it's progeny data or genomic data or individual or measurements, whatever it might be, the accuracy of EPDs is going to increase, and those EPDs are going to become a more valuable tool. So I really like this graph I have at the bottom. The very pointy, kind of curve we see there in the middle, that would represent a high accuracy animal, right? So there's not a lot of variability. We have, I won't go into pure statistics, but the range of outcomes that is underneath that curve there in the middle of the solid line, it's a lot tighter grouping, right? We have a lot less variance, whereas if we have a low accuracy EPD, is represented in the dotted line, sure, the average EPD in this example might be 0, but realistically, you could get an outcome of +3 to -3, because of that low accuracy. So another way to look at it, again, these are just kind of some arbitrary values that I pulled up, but the accuracy, the red box you see, it's going to be related to the statistics. If we have an accuracy of 0.05 to 0.1, even if that calving ease direct, that CED EPD says it is 7, in reality, if we have that breeding, the true value could be anywhere between a 14 and a 0, right? So as we increase the accuracy, we get a tighter target and closer again to that true value. So we have the green ovals of an accuracy of 0.29 to 0.35, and then maybe we submit a lot of data. We have a lot of flushes. Maybe it's a heavily used bull, and we get that accuracy over 90. This just goes to show that the higher the accuracy, the closer to the true value and the closer predictive capability that you're going to have as accuracy increases. So when we talk about improving EPDs, I've been talking about bulls a lot, because when we think about improving our herd, really a lot of the genetic improvement is going to be attributed to sire selection, right? So whether you're using bulls and natural service or whether you're using artificial insemination, if everything's going well, right, we're going to keep cows in our herd for a long time. So cows with longevity are going to be more profitable, so they're going to stick around in the herd longer. So they're going to have the same genes, right? Cows, if they're staying in the herd, they're going to have the same DNA, they're going to have the same genes throughout their whole lifetime. It's these breeding selections and the sires we bring in are how we are going to drive our genetic improvement. So we can, I have here, 50% of the genetic improvement from each breeding is going to come from the sire, right? Half from the sire, half from the dam. But if we go back, 87% of the genetic composition of our calf crop is really going to be determined by the sires used over the last 3 generations. So when we talk about genetic improvement, a lot of the time we're talking about sire selection. So there's a lot of different ways we can go about genetic improvement and improving that, the average traits that we care about. There's a lot of different ways to do that, right? So we can talk about a cross-breed variances and within breed variances, right? So I have an Angus bull that's actually hometown, another heavily used bull on the top left. We have a Charolais composite bull. I believe that's Texas Tornado, a kind of heavily used club calf bull on the top right. And I found a Brahma bull to put on the bottom. If we use these three bulls on the same group of cows, we're going to get three very, very, very different groups of calves, right? So a lot of this, how we measure genetic improvement is going to a lot have to do on what our goals are, right? So if we are in South Texas where it's really hot and we have a higher pest pressure, we're probably going to be looking at some Brahma genes and maybe making some Brangus crosses or some 3/8 Brahma Angus crosses because that is better fit to our environment. We have less of a pressure and less of a drive to use Brahma cattle up in New York, right? We're not getting near hot and humid enough for that to be as viable and as economically important for us. So a lot of this is going to depend on what your goals are, on what kind of sires and what kind of breedings you're using. So we've been talking about EPDs, which are, like I said, measured and tracked within individual breeds, but we can also talk about crossbreeding programs as well. So different traits have different levels of heritability, right? So our carcass traits, heritability is basically how quickly you can make genetic improvement and how quickly you can change a trait from generation to generation. So carcass traits are going to be pretty highly heritable, meaning we can make a lot of change in marbling or subcutaneous fat at the 12th rib or our carcass weight. We can make a lot of change of that generation to generation. Growth traits like weaning weight and yearling weight are going to be pretty moderately heritable, so they're not going to change as fast as our carcass traits, but we can still make some pretty significant change generation to generation. But things like fertility are going to be pretty lowly heritable, right? So if you have a cow that is or a heifer that just doesn't want to get bred, and for whatever reason she's just a not fertile, very low fertility female, it's going to take a lot of generations to turn that around. But we can talk about crossbreeding and using heterosis or hybrid vigor or this ability for the offspring to outperform the parents. If we use targeted crossbreeding and use, maybe a Angus Simmental or an Angus Hereford, white-faced Baldies are always very popular for a kind of a maternal outcross. When we use crossbreeding systems, we can make a lot of genetic improvement and turnover on these offspring on a generational basis. So we can talk about maternal versus terminal breeding. And again, what are your goals? Are you selling your entire calf crop every year on a grid basis or sending them out to a feedlot and you're not retaining any females and maybe you're buying your females from an outside source? Well, you probably don't care as much about your milking ability, right? So that milk EPD is going to be a lot less valuable to you if you are selling animals based on the grid because you're not retaining females, right? You care a lot less about scrotal circumference if you're not taking any bulls, right? On the opposite side, if you're retaining females and adding replacement females to your herd off your own breedings, things like calving ease and weaning weight are probably going to have a little more weight to you than as it in a situation that is a purely terminal system. So, really we talk about what's the best bull or what's the best breeding, program. The best breeding program is one that takes into account, the end market and production scenario, right? There's not a universal bull that works good in every single situation, and that is the ideal bull. The ideal bull and the ideal cow and the ideal breeding is one that works within your production scenario and is the most profitable for you as an individual. So I know this is a little bit small, so maybe y'all can zoom in or pause this when you go back over the recording. But I pulled this again. It'd be from the Angus Association. I have some kind of the top percentile, the median or the average percentile, and the lowest percentile. I wanted to talk about kind of some different traits specifically and what maybe some of these EPDs mean as time has gone on, and we've been able to measure more traits, and our understanding of DNA and genetics has increased. With that, we've added a lot of EPDs, and so they can get kind of confusing and a little bit intimidating. to producers that might be new to EPDs or new to the cattle production. So I wanted to go over some of these and talk about some different scenarios where traits would be important. So I talked about calving ease and weaning weight and yearling weight. That's going to be on our production EPDs on the far left. CED meaning calving ease direct, BW meaning birth weight, WW weaning weight, YW yearling weight. These are going to be pretty consistent across all breeds. So not it's important to point out that not all of these EPDs will be in every single breed database, but things like calving ease and growth and measures of carcass and milking ability, those are going to be pretty consistent across. There's going to be some measure of that. They just might have a different nomenclature, different system. So, we talked about what traits are important in different scenarios. PAP stands for pulmonary arterial pressure. We hear that a lot in kind of the mountainous West and areas like Colorado or Montana at a higher altitude. That's an EPD that they're going to be looking at specifically for their breeding stock and their bulls and their heifers and their females because it is relevant to their system, right? So at a higher altitude, we can have some issues with blood pressure. But if you're a producer in Louisiana, or a very sea level area, you probably really don't care about PAP unless you're sending those cattle off to, you're selling breeding stock to a mountainous area, and that's where your, consumers or your market is. We can also talk about HS, the hair shed, right? So in the southeast, we have the challenge of higher temperatures, and we're in the fescue belt. So we'll pay a lot more attention to a hair shed score because that will have a direct impact, excuse me, on how animals will, thrive in high heat environments and these fescue dense environments where having the ability to shed their hair, excuse me, will be favorable and let them dissipate heat more readily. So, every EPD is not going to be valuable to every producer, and also not every production scenario as well. So things like our calving ease, direct weaning weight, yearling weight, dry matter intake, and marbling, that's going to have that's going to have be a direct measure or a direct impact on that first generation. So we have our bull here, we have hometown on the left, and hypothetically, this Black Baldy is a daughter from directly out of hometown. The EPDs of CED, calving ease, weaning weight, yearling weight, that's going to have a direct impact on her. But the EPDs of milk and calving ease maternal, that's going to have an impact on the offspring of that heifer, of that female, right? So different EPDs are going to apply differently, again, based on the scenario and based on your production system. So, I keep coming back to maternal versus terminal, you're going to want to educate yourself and understand different EPDs depending on where different economic traits are valued to you. So in recent, in the last couple decades, the breed associations have put out what we call dollar indexes or dollar values. And really, these are tools that combine a lot of different EPDs, and they're economic selection tools that can put selection pressure on a pool of EPDs and a group of EPDs, and will help producers compare different breeding stock and make decisions that are pertinent to their specific situation. So I'll go through a few of these. We have the maternal wean calf value, or the dollar M. That's going to put higher weight on the calving ease, weaning weight, milk, heifer pregnancy, docility, and our foot measurements, our claw and angle measurements. And that is all these formulas for these dollar indexes are not going to be shared, right? They're not, how each trait is weighted is not public knowledge. That is, kind of a specific, I guess, intellectual property of the breed association that produces this dollar value. But the units on these are going to help producers make these decisions. So what I have outlined in the green box, so looking specifically at the dollar M, at the top percentile, that very top row, we have plus 100, and then at at the bottom, at the 95th or the bottom fifth percentile, we have plus 32. That basically just means that if you were to use a bull that was in the had a dollar M of plus 100 and a bull that had a dollar M of plus 32, you would expect a monetary difference of $68 um, favoring that top percentile. So it's kind of a little harder to conceptualize this when we talk about dollar M, but when we talk about a say a weaned calf value or dollar W that looks at birth weight, weaning weight, milk, and our mature weight, that dollar W. So in this example, a dollar W of 91 versus a dollar W of 61, you could expect if you are selling weaned calves that bulls that have a dollar W of 91, you will get on average $30 more per calf if you're selling them at weaning over calves from a bull that sired by a bull with a dollar W of plus 61. So there's a variety of different dollar index traits, right? So we have a grid value one that focuses on some carcass traits. We have a beef value that is kind of a little more general and looks at some growth traits, some dry matter intake and carcass traits, and a dollar C, which is basically combining dollar M and dollar B. You can look up these specific definitions in the breed of your choice. Like I said, this is an Angus specific example, but Hereford Association, Simmental, Charolais, they're all probably going to have some index traits that will really helpful as a tool that you don't have to maybe look at 20 different EPDs to make a comparison. You can use some of these dollar index values that pool a lot of these traits together to help you make some pertinent breeding selections and make genetic improvement based off your specific production system. So here recently, with the trend of beef on dairy breedings, we also have some of these, beef on dairy specific dollar indexes as well. So in the Angus Association has the dollar AH or Angus Holstein or the dollar AJ Angus Jersey. So that's, looking at some calving ease, some growth traits, some dressing percent. Really, as we continue to get feedback from producers, and as our research and understanding of genetics increases, breed associations are putting out more EPDs and more index values that are helping producers and adding tools to the tool belt to be able to make more informed decisions on our breeding strategies. So moving from I guess EPDs heavies and getting into actual I guess the process of breeding or the thought of breeding, I wanted to do a little bull math, right? So talking about in some slides after this, I'll get into some numbers on artificial insemination versus natural breeding, but people you go to a bull sale, no matter where it is across the country, and maybe if you're new to cattle production and you wonder, why is one bull going for $2,000 and why is one bull going for $6,000? Is it really worth $6,000 to me? Again, you have to go into your production scenario and what is valued and what goals you are trying to achieve on how you value bulls, right? So I have this chart here on the right, a bull cost per cow exposed, right? So this is basically assuming a 5-year useful breeding life. We have equal maintenance costs on bulls, equal salvage values. And when we're done with this bull, we're saying that the $2,000 bull and the $6,000 bull, when we're done with them, we're going to sell them at the same price, right? So just looking at, the number of cows and the number of heifers, the number of females you're breeding, is going to have a significant long-term impact on the profitability of what bull you select, right? So if we have more cows that we're breeding each season, the cost of that bull is going to be dispersed over, more cows, and maybe that it's going to be diluted. So if you have more animals, it might be more valuable for you. Or if you think about things not purely as this, all right, today I'm buying a $2,000 bull versus a $6,000 bull. If you think about it in the long term, it might pan out a little bit differently. So I pulled some numbers from the Oklahoma National Stockyards. This is again just kind of an average for January, the January 28th report. This would be kind of a good barometer or dipstick of the market across the entire country. So this is the average of five weight steers and heifers, M&Ls, medium and large framed feeder calves that are number one, so heavily muscled. So we were looking at on the 28th, $336.50 per hundredweight, or if you want to think about it per pound, $3.365 per pound is what weaned calves were selling for in the Oklahoma stockyards on the 28th. So if we were to put a different lens on this, right? So if we're looking at a bull that has a weaning weight of 85 versus 45, obviously, weaning weight and yearling weight are pretty heavily looked at EPDs by cattlemen across the country. Pretty much, the growth potential we sell on the pound, right? We sell based on weight, so these are going to be pretty impactful EPDs that are going to influence maybe the value of a bull at a sale. If we look at this, 40 unit difference in weaning weight on average, again, we might have some bigger calves, we might have some smaller calves, but a bull that has an 85 weaning weight versus a 45 yearling weight, we can expect on average return $133 per calf difference. So again, looking at these, when we talk about buying bulls and we want to have them functional and breeding in our herd for a long time, it might make more sense, right? If you pencil out and do some of this math to spend a little bit more on the bull that day and bite the bullet. But over time, if you have a bull with higher genetic potential and a high accuracy and a high weaning weight, and you're selling calves at weaning, that difference adds up, right? So maybe that $5,000 bull is looking a little more enticing when you know that you can get $133 more per calf on average. If we want to look at it from a conception rate also, so this is assuming equal. You're selling calves at the same price, but the quality of the bull, not just the EPDs, but again the phenotype as well, making sure that he is getting cows bred and coming from a viable quality operation. That's going to have a big impact as well. So if we don't have a fertile bull and we're not getting our bulls BSE tested, breeding soundness exam tested, and he's not having great semen quality and therefore has a low conception rate, over time, that's going to make a big impact, right? So maybe we pay a little bit more for a bull that comes from a quality operation that we know has a good track record of very fertile bulls to ensure we're getting a great conception rate and a higher conception rate, because open cows, right, are by definition not going to give us any return. So there's a lot of different factors. I talk about balancing genotype and phenotype. It's not just genetic factors, but also how the bull looks and making sure he has the type and the visual characteristics that you want, but also making sure that bull is coming from a quality background and quality. He's vaccinated, he's breeding soundness exam tested. He's going to be fertile. There's a lot of different things that weigh into the value of an animal more than just the specific price tag. Again, it's the bull is going to be the driver of our genetic improvement, and it's going to be a long-term investment. So we want to make sure that we're buying them right, and we do our homework and do our math on the front end to make sure we're making a quality investment. So as I'm kind of wrapping up, I wanted to talk about natural versus artificial, natural breeding versus AI or artificial insemination. I know this is a beef group, but I found this picture on the right for artificial insemination. It's kind of plays into, I guess, some of the labor struggles, for lack of better words. I just thought it was funny. So I thought it'd be good to keep y'all's attention as I've been talking for a while. You hear a lot of pros and cons on should I buy a bull? Should I use AI? And there's really, again, it depends on your program, it depends on your resources, and it depends on your goals, right? So when we're making some comparisons right off the bat, the bull does the work. If we're talking about buying a bull and naturally covering those cows, you put the bull out with those females, and he's gonna do what nature and God intended, and he's gonna get it done, right? Assuming that the female, the cow or heifer is fertile and the bull is fertile, he'll get her bred. AI requires some level of training, whether you take a class to get trained on how to AI or you hire a technician to breed your heifers and cows. There's going to be some equipment costs, right? You're going to need a liquid nitrogen tank to store that frozen semen You're going to need some working facilities, right? A bull goes out in the field and he does his thing. You're going to need to restrain that cow to breed a heifer or a cow safely and effectively. So you're going to need to invest in a head gate or a squeeze chute, some level of working facilities. You're going to need, AI sleeves. There's a lot of different equipment and training that goes into AI breeding that on the front end, provides more of a cost, more time and labor cost on the front end compared to just buying a bull. When we talk about the process itself, again, the bull does the work, right? So a bull can go out in the herd and he knows when she's in heat and she's receptive, and he can breed her multiple times, whether if she's ready at 3 in the morning, right? That bull's going to know, that bull's going to kind of get her up and he's going to do his thing. And we don't need to be as vigilant maybe as we would with the AI, whereas I always recommend folks, I guess technically you can, go out and watch heats and just look for natural cycles and, sit out in the field and figure out when your females are coming into heat. But ideally, to make the most and be the most efficient with an AI protocol, you need to synchronize them. So you need to use some level or I recommend at least using some level of CEDARS or prostaglandin or GnRH, some sort of synchronization protocol to make sure that all these females are coming into heat at the same time, and you know exactly when you need to have your technician there or when you need to be checking heats within a 24-hour window to know when that female is ovulated and when you have the best chance of breeding that female and making sure that semen results in conception and a confirmed pregnancy. So there is a level of timing and a level of, again, of management involved in AI that's not necessarily involved with bull breeding. I say there's no need for timing, sort of. On the bull side, I still always recommend that you have a defined breeding season. So keeping that bull out with your heifers and cows maybe for 45 days or 60 days, making sure they're out there for 2 or 3 heat cycles so or at least have a good prediction of when those calves are coming, and you can tailor your resources effectively to make sure that you're calving when you want and you are managing your feed resources and you're not overworking your bull, keeping them out there year round. So there is some level of not necessarily synchronization, but still management that comes, or at least I recommend that should come with bull breeding. But lastly, we talk about, the bull does all the work on the natural side. Well, one of the downsides is you have to maintain a bull throughout the entire year. So just because you have put your bull in for 45 days to breed your females and you've pulled him out, maybe your neighbor's heifers and cows are coming into heat, and maybe your fence isn't maybe up to snuff. And now that bull smells those cows coming into heat next door, and if he smells them, he's probably going to walk right through that fence. So you need to put into consideration the cost of maintaining a bull, right? So you have to feed him, you have to have a different level of confinement and management. Bulls are a lot more harder on fence than yearling calves are, and you have to account for that. Also, we talk about, we want to keep a bull around for a few years. We don't want to be buying a new bull every year. So with that, we're inherently kind of locked into our genetic potential. That's the really, really big benefit of AI and artificial insemination is you have access to a wide range of genetics, and you can specifically mate one female to one bull, whether that bull's in Canada or Brazil, or if you can buy that semen and get it, shipped frozen to you, you can breed that female to that bull. So you can really rapidly advance your genetics using AI, and that's really the big opportunity is being able to use all these selective breeding tools at our disposal. There's a lot of different semen companies out there, our Gen X, our Select Sires, ABS, boatload of semen, commercial semen producers. And you can spend as much or as little as you want on a straw semen. So probably on average nowadays, for a quality bull, you're going to be looking about $40 a straw. But you can spend up to, hundreds. I've seen deceased bulls with a lot of genetic potential going for thousands of dollars a straw, right? So you have a lot of different genetic breedings and merit at your disposal when you're using AI. And we have to think about also, again, our production scenario. If we're retaining our females, that means, we're keeping some amount of our heifer calves to put back in the herd. We probably want to be cycling our bulls and getting a new bull every 3 years or so to prevent inbreeding. So we are not lowering, raising the inbreeding coefficient and having some, higher risk with bull to daughter matings. That means we're going to be want to be buying a new bull every 3 years, 3 to 5 years, or separating our heifers. And there's another level of record keeping to making sure we're not inbreeding our animals. So, all this aside, what are my take home points for, genetics for the cattlemen? I've said it all throughout this presentation, define your production goals, right? If you don't have a target, where do you aim? So kind of tongue in cheek, right? This picture I have on the right of this bull trying to breed this heifer, I doubt he's going to get that heifer bred. That's probably not going to, he's got that roof right over his head. He doesn't really know where to aim. That's not going to result in a successful breeding. Similar to, what is a good bull for you? You have to define your production goals. If you want to increase carcass merit, you want to increase carcass weight and marbling, well, you should probably be, selecting for bulls and females with high genetic capabilities for marbling and high genetic capabilities and potential for yield grade and quality, right? So the best bull is the right bull for your situation. Do your homework, right? So I talked about how we're getting more and more EPDs and we're getting more and more data at our fingertips and our disposal. You can get a little fatigued, right? So I pulled this from the Clemson bull test and bull sale coming up here soon. We have pedigree information, we have EPD information, we have bull test performance, birth weight, ultrasound information down there. There's a lot of data at our disposal, and it can get pretty fatiguing if you don't know what you're looking at. If you want to go to a sale and buy a bull, it's probably best you do your homework a couple weeks in advance and know what all this data means and know how it relates to your situation, what data you need to look at, and what data might not be as important to you, right? So if you don't measure it in your cow herd and you don't measure it in your progeny, you don't really know if you're improving or not. So you can go out there and look and say, yeah, I feel like this year's worth of calf crop looks like they weaned heavier than last year's. But really, maybe your eyesight's bad. Maybe it's rainy out. Maybe they have a different hair coat. Who knows? Unless you're actually measuring it and putting some hard numbers behind it, it's kind of hard to know if you're improving. So do your homework on your production side, measure the traits that you think are important for you, and also do your homework on bulls and cows, breeding animals that you're potentially bringing into your herd. Make sure you're looking at the right things and knowing what all that means. Reach out to your extension agents, reach out to your land grant university. This is what we're here for, to help educate producers. There's a lot of different options. There's a lot of high quality bull and replacement female producers across the country. There's a lot of different semen available across the country and across the world. Don't pigeonhole yourself just because your neighbor produces bulls. Don't be afraid to look out and branch out a little bit, right? There's a lot of opportunity out there. You just kind of got to do some back work and some leg work to make sure you're taking advantage. And remember, EPDs and genomics are not crystal balls, right? So we need to, they're not going to predict exactly what the calf crop looks like. EPDs are comparing averages, but there's still a range of outcomes, right? Every bull will throw a good one, every bull will throw a bad one. But we really need to balance our genotype and our phenotype. So our genetic potential and how these animals actually look, right? So just because an animal has, maybe a top 1% in weaning weight and yearling weight and marbling and milk, and, maybe he's just top 1% across the board. He has the best EPDs. We found a unicorn, but he throws calves and they're just crippled and ugly as sin, right? And they just, these calves can't even walk to the feed bunk to grow. That's probably not an animal if he keeps throwing crippled calves, or he has, a genetic defect that is, causing cows to abort. It doesn't matter what his genetic potential is, but he's not producing calves with the look and the traits that are profitable and important to us as producers. And remember, genetics are a long-term investment, right? So we talked about different heritabilities and how different traits can be improved at different rates, but it's not going to happen overnight, right? So genetics are a long-term investment with long-term implications. So I've been I go to a lot of talks and I listen to a lot of professionals. And I love this picture here on the right that kind of shows our phenotypes across the decades and across the years, right? So these are on the far left of this image. These are animals that were winning ribbons and winning banners back in the day, right? I've heard that back in the 70s and 80s, if you could send your kindergartner or your toddler to walk under your bull and that toddler didn't have to duck, by God, that was a great bull. If you could make them framey and tight ribbed back in the day. But we have definitely changed the type of cattle that are important to us, right? So no matter what trait is important, if it is economically incentivized, livestock breeders will find a way to change animals and change our phenotypes. So it's not going to happen overnight, but if you make the investment and you put in the time and the effort and the work and continue to measure traits that are important to you and make, deliberate breeding decisions, you can make animals and make a genetic pool that is, favorable for you and favorable for your production scenario and your economics as well. So with that, I'll provide my contact information. I've talked to you all long enough. I made it about an hour. So I would love to take any questions. And if you have any other questions that come to you later, please feel free to reach out to me. For my folks in New York, I am based out of Ithaca, but I cover the whole state. So, I tell folks I got started in September, but I go where the cattle are and I go where the producers are. So please feel free to reach out. I'm still making connections early on, having just started in September, but I'm really excited about the potential of cattle production in New York specifically, and I'd love to help out where I can. So with that, I'll happily take any questions. Let's see, I can stop sharing my screen.
Thank
There
you
we
very,
go.
very, very much. That was great. That was a lot of really good information that we had. I do have one question, clarification, I guess. I know we have a lot
Mhm.
of beef producers on our webinar tonight, but we also have some sheep, goat, pig, that sort of thing. Just to clarify that this information is obviously translatable across species, there might be some different terminology, right? When you're looking at the different genetics, obviously, but all the information's pretty much the same. Genetics is genetics at the end of the day, right?
Correct. So we're going to be measuring different traits, right? So swine, we can talk about our SPI. We can talk about litter size. We can talk about, 21-day litter weight. For sheep, we have our EB estimated breeding values. We can talk about singles versus twins versus triplets, scrapies, codons, Qs, and Rs. But at the end of the day, there is going to be some measure of progeny growth potential. It might be under a different term, a different name, right? So EPDs are a term that are used a lot for, beef producers, but, like you said, genetics are genetics. And whether it's a sire and a dam, a ram and a ewe, or a boar and a gilt, right? They're still going to pass on genes. One gene's going to come from the male side, one gene's going to come from the female side, and how they combine and how they are presented in the progeny might be measured with a different nomenclature, but there's still going to be something out there and some level of genetic measurement that we can track progress. Yes. So genetics are genetics across species. They just go by a few different names.
Great, perfect. All right, so I will go ahead and stop recording and I will open it up for questions. We did leave a little bit of time at the end, so that was the plan. Hold on here.